Warning, some of the things shown are extremely dangerous and should only be done with supervision or proper safety precautions.
Trust me, it can blow up.
You don't want to die.
I'm Nick.
I'm Dawson.
And this is Jacket.
Mythbusters.
The following experiment shows how thermodynamics can be involved between a reaction of dry ice and magnesium. Fact 1. Magnesium can pull oxygen from other things other than air. Thermochemistry is like the study of the heat released and stuff, like as a result of chemical reactions, you know what I'm saying? The standard molar entropy of magnesium is 32.7 joules. The molar capacity for magnesium is like 24.9 joules. Dry ice releases CO2, which comes off looking like smoke.
Endothermic reactions take in energy. Exothermic reactions give off energy. This is an exothermic reaction. Magnesium burns at 2000 degrees Celsius. In this reaction, energy isn't gained, it's lost. Line.
The products in this reaction are magnesium oxide and carbon.
Fire extinguishers contain CO2 and dry ice gives off CO2. So the fact that magnesium will be lit when there's CO2 around is proof that a fire extinguisher would not help in a magnesium fire.
Daban Daniel, dab! Enthalpy is a measurement of energy in a thermodynamic system.
Entropy is the measurement of disorder or randomness in a chemical reaction. Gases have the most entropy, liquids have less entropy, and solids have the least entropy. What?
Don't take the AP test. Don't do it.
Carbon dioxide and carbon have the most entropy in the reaction. But magnesium and magnesium oxide have the least.
All reactions prefer low energy, enthalpy, and high disorder, entropy.
Dry ice doesn't melt, it evaporates in a process called sublimation. The fog you see around the dry ice is actually a mixture of cold CO2 and the humid air around it.
If the carbon builds up too much and there's no way for the carbon to escape from the dry ice, then it could potentially explode. So that's why we have little grooves, or we have an offset, so that the carbon can escape and you can see the smoke escaping during the experiment. So the equation here is going to be Mg plus CO2 yields MgO and C. The smoke given off by the equation is the C, and what's left over is going to be magnesium oxide, the MgO.
To safely conduct this experiment, I would recommend flame-resistant gloves, as well as flame-resistant coat and pants, goggles, and possibly a face mask if you're really worried. There are explosions that are possible, and there is definitely flames, so be careful.
It's coming out at 0.18 ounces.
This is 5.1 grams.
We have our dry ice. We'll lay the dry ice out. You need to drill in. We're about midway through on the
on the ice block. And we'll set our ice block here onto a pad that is fire resistant. We need the magnesium. Okay, so the two blocks will go together to form a tight seal with just enough so that it can relieve the gases. Ignite. You've got ignition. Place the dry ice over it. And you can see that it burned up complete with just your carbon. Got ignition. Place the dry ice over it. And my background is 34 years in the fire service. I went through the ranks in Colorado. I retired as a fire chief, and then I went into the community college system and became a director of a fire science program. In my years in the fire service, I was also a hazmat technician, so we dealt with many hazardous materials such as magnesium. Without that background, I wouldn't be able to explain the things that we try to accomplish here today. During my tenure at the community college level, I used to teach hazmat and also the fire academies. One of the things that we were looking at today is that magnesium doesn't really need an oxygen source because it pulls oxygen from whatever source it can. In real life situations, you had things such as Volkswagen blocks, engine blocks that were made from magnesium. You also have wheels that are made from magnesium. So when we go out to fight fire, as soon as you hit the fire with water, it explodes because it adds extra resources of oxygen into the system. So in this one, you saw that even taking out the oxygen, it'll still pull that oxygen from some source, and you'll still have a very hot and bright burning fire.
Wondering, that's dry ice. Why doesn't it melt? You know, it gets up to 2,000 degrees Celsius, right? That's a great question. So let's examine it a bit further. First, let's calculate how much carbon dioxide is required for the reaction. If we use 16 grams of magnesium with a molecular weight of 24 grams over moles, then we have 16 grams over 24 grams over moles. And that equals 0.66 moles of magnesium. So according to our balance reaction provided, we need half this number of moles of CO2 to equal 0.33 moles. Given a molecular weight of 44 for CO2, that's 0.33 moles times 44 grams over moles equals 14.67 grams, roughly half an ounce. So we get it, just tons of free energy, right? And why doesn't that burn the block, right? That's a great deal of heat. Simple, actually. All of the free energy actually went into making the bright light that you saw, instead of actually generating heat to burn the block.